Hello, so today we will start a brand new series which is a guide to computer redstone. In this series, I will teach you everything about computer redstone. And if you haven't subscribed, make sure you do because this series will continue and there will be many other awesome content coming soon. So let's start with today's um, topic, which is Introduction to Binary and Hexadecimal. So even if you know what binary and hexadecimal are, you should watch this because this will about hexadecimal and binary in reference with Minecraft. So as you can see, I have made everything. So first I will explain and then show you practical application and how to use it. So let's begin. The three main types of number systems are binary, decimal, and hexadecimal. Each system has a different number of one-digit numbers. For binary, it's 2, for decimal 10, for hexadecimal 16. And this is all the things you need, all the number systems that are going to be useful in computer redstone. So I will now guide you to each one of them. So let's start decimal. Decimal system is the one we use in everyday life to count and calculate. Decimal means 10. Decimal has 0 to 9, which are the 10 single digit numbers in decimal system. In decimal, after the number 9, two-digit numbers start. The first two-digit number is always the number 10. So as you can see, from 0 to 9 there are 10 single digit number. This is why it is called decimal, which means 10. So decimal system is what we use every day. So there is nothing really special or anything that you don't know about decimal. So I guess that's enough for decimal. Now let's move to the next one, which is hexadecimal. Hexadecimal means hex plus decimal, which is 6 plus 10 equals 16. Hexadecimal has 16 single digit numbers. The 16 single digit number are 0 to 9 and then A, B, C, D, E and F. So don't confuse A, B, C, D to F as letters in English because these letters are actually numbers in hexadecimal. So in hexadecimal, after the last single digit number, which is F, two-digit number starts and the first two-digit number is always the number 10. So make sure you don't confuse the alphabets with alphabets because these alphabets are used as number in hexadecimal. So we will always call them A, B, C, D, E and F in hexadecimal. And they represent 11, 12, 13, 14, 15 and 16. No, it's up to 15. Okay. So it's 10, 11, 12, 13, 14, 15. So I will show you very soon. So next is in Minecraft, we use comparators to represent the 16 numbers in hexadecimal. Comparators can emit 15 different signal strengths which are used as follows. So comparator, if off, it represents a hexadecimal number 0, and if the signal strength is from level 1 to level 9, it represents the hexadecimal number 1 to 9. And if the signal strength is 10 to 15, then it represents A, B, C, D, E and F. So that's basically how it works. So basically if the comparator is off, then the number is 0. Otherwise it's the same as the signal level, as the power of the signal. So this is how we can store 16 single digit numbers in a comparator, making comparator a hexadecimal system. So here you can see the redstone line is currently off, which means it's representing the data of 0. So right now this comparator is at 0. Now every time I will click a button, this thing will raise the signal by 1. And this is how we will count in hexadecimal. And the numbers will be represented by these lamps. So let's show you. So the last lamp is F and the first one is 1. So let's start. So as soon as I pulse this, you can see 1, 2, 3, and so on. So I guess I'll just spam it for now just to demonstrate. So if I keep clicking, I will eventually reach the end. Yeah, so as you can see, I guess we are on the number B. Yeah, we are on number B. So now it's number C, number D, number E, and number F. So as you can see, we reached number F, which is the maximum amount of single digit numbers a comparator can store. So now if we click this button, everything is clear and back to 0. So that's the hexadecimal parts. Now let's come to binary, which is binary is very important in computer devices, even in real life and in Minecraft Redstone. So let's say binary. Binary means by or two. Binary has only two single digit numbers. The two single digit number are 0 and 1. In binary, after the number 1, which is the last single digit number, two digit numbers start, and the first two digit number is always the number 10. So in binary, there's a different way we represent numbers. So here in Minecraft, we use redstone signal to represent the two binary numbers. Redstone can have two states that are on and off. If signal is off, then it's 0 in binary. If on, then it's 1 in binary. Now I'll show you how to read binary numbers. So in binary, 0 is 0. So it's in reference to decimal. So the 1 of binary is 1 in decimal. But in binary, if you write 10, then it's 2 in decimal. 11 is 3, 100 is 4, 101 is 5, 110 is 6, 111 is 7, and 1000 is 8, and so on. So here I have 4-bit binary data. So I have 4-bit or 4 digits of binary data. I will just demonstrate on that about how we count these numbers, how to determine that which combination of 1s and 0 will represent what number in decimal system, because it's really confusing when you see 10 or 11 representing 2 or 3 and 1000 representing 8. So I'll just show you and explain you what exactly is going on over here. So the first thing is, since in binary we have only one wire on which we can represent only two values, which are 0 and 1, we can't really write the number 2 because we can only write 0 and 1. So we have to use the combinations of 0 and 1 to represent all the different numbers. And so here I will show you how exactly we do that. So as you can see here, the number 8, 4. So let's start with this. So this is the first digit of binary number, which can hold the data of 0 and 1. Hence you can see the sign with number 1, which means it can hold data only up to number 1. It represents the number 1 itself. So if we turn this on, it will represent that the number is 1. Okay, so let me just do that. So if I click this is number 1. Both in decimal and in binary, it will remain the number 1. So now if I want to represent number 2, what do I do if I want to represent number 2? This is just 1. Okay, so this thing is very easy. So each line it's raised by power of 2. So here it's 1, then next line will be 1 into 2, which is 2. So if I want to represent the number 2, then I will use the lever on number 2, and as you can see, after number 2 we have number 4, then number 8. Then if I want, I can add 16, 32 and 64, 128, 256 and so on. So these levers represent a particular number over here. So I'll show you real quick. So if I want to write 2, so I will just flick the lever which says the number 2. Okay, but the thing is, you can see here 1, 2 and 4. So if I want to write 3, how am I going to do that? So I'll show you what exactly you need to do. So if you want to represent the number 3, you have to turn on the lever of number 2, and then you have to turn on the lever of number 1. So for example, if I turn on the lever of 2 and 1, it will represent the number 3. So let me just do that. So 2 plus 1. So since we have both the levers that represent 2 and 1 active, we are going to add this number in order to determine what number it represents. So 2 plus 1 equals 3. So this is 3 in decimal, but in binary you can see it is 1 and 1. If lamp is active, it's 1, and if lamp is off, it's 0. So we can see the number is 1 1, and if you can see in this book, the number 1 1 represented the number 3. So now if I want to represent number 4, I will just flick this lever, and now if you think about it, the lamps that are turned off represent 0. So this number is actually 100, which is 100. So if you want to represent the number 4 in decimal, the number 4 of decimal, you need to write number 100 in binary. So that's for number 4. But what if I want to write number 5? So I have turned the number 1. So 4 plus 1 equals 5, and its binary number is 101. If I want to write 6, 4 plus 2 is 6, binary number 110. If I want to write 7, 4 plus 2 plus 1, 7, binary number 111. If I want to write 8, then just turn this on, and binary number 1000, as you can see in this book, 1000 equals 8. And if I want to write 9, then 8 plus 1 will represent the number 9. So here 8 plus 1 equals 9, and in binary that's 1001. If I want to represent number 10, 8 plus 2 equals 10. In binary that's 1010. If I want to represent number 11, then 8 plus 2 plus 1, 11. In binary that's 1011. Okay, and now if I want to represent number 12, then I will turn this off. 8 plus 4 equals 12. In binary that's 1100. Okay, and if I want to represent number 13, so 8 plus 4 plus 1, 13. In binary that's 1101. If I want to represent number what was the count? Oh, I forgot. So yeah, 8 plus 4 plus 2, that's 14. Yeah, so for 14 we have 1110. If I want to represent number 15, 8 plus 4 plus 2 plus 1 equals 15, and the binary number for that is 1111. And if I want to represent 16, then I need to add another bit or another digit to this thing. So if I make a new digit, the signboard to that will represent the number 16. If I make one more, it will represent 32. If I make one more, 64. One more, 128. And if I make one more, 256, and so on. So it keeps on getting double. Each line will hold the value twice as much as the previous. So you can see 1, here's it 1, and here's it is 2. So here, right now, if you can see this, I've added 2 plus 1, which means 3. So in binary we get the number 11. So this is how we determine and use the hexadecimal and binary numbers in Minecraft Redstone, and the binary numbers are used in similar way in real life computers that you are using right now to watch this video. So this is how it works. And if you're interested in learning computer redstone, this is just the basic, this is just the first episode. If you're interested in learning everything you see on my channel, then this series is going to absolutely help you. So see you next time.